Unit 4 Revision Gold. We are doing question 6, which is asking us to implicitly derive these functions, or these. Okay, so let's start off with the circle. If we implicitly derive, we d dx x squared, we d dx y squared, we d dx 25. The derivative of x squared is going to be 2x. The derivative of a constant will be 0. Y squared, remember it's our known one, 2y dy dx. Comes from chain rule. It's the derivative of the y squared and then dy. So we end up with 2y dy dx equals negative 2x. So dy dx equals negative 2x over 2y, or negative x on y. You should remember that d dx y squared is 2y dy dx. That should be something you know. D dx x squared, d dx 4xy, d dx 3y squared, d dx 6. Okay, so we're deriving everything with respect to x. I would start by doing that as my first line. Do the easy one, that's 2x. We know that's 0 because it's a constant. Our y squared we know. Now because there's a 3 there, instead of 2y, it'll be 6y to y dx. Then we have the harder one, which is our product rule. So I'm going to split it up into 4x and a y. So if I derive that, remember product rule is u v dash plus v u dash. So essentially we're just doing that. So I'll have 4x and then a y dx plus 4y. So 4 is when I've derived that and I've left y alone. This is when I've left 4x alone and I've derived y. Whichever order you put that in is fine. Now I've got 4x minus 6y to y dx. I'm going to take the 2x, take the 4y to the other side. I am trying to isolate dy dx on its own. So I get dy dx, negative 2x minus 4y over 4x minus 6y. So I now have done it. What do you notice about all the coefficients? All the coefficients are multiples of 2. So we would simplify that to negative x minus 2y over 2x minus 3y. Just simplifying that fraction down. Our last one, oh, we've got a trig in this one. D dx sine x, d dx x squared. Oops, that should have been an equals. Equals d dx y squared. Derivative of sine x is cos x. 2x, this is 2y dy dx. So obviously cos x plus 2x on 2y is dy dx. So even with that trig in there, just follow your rules through and you'll be fine.